What are linked lists? They are a generic data structure typically made from nodes, and they are a form of a sequential list. Like I said, linked lists are usually made using nodes and are easiest to understand that way as well. Here's a node that will be a part of our linked list. We call this the head because it represents the start of our list. Head is just the global variable which allows us to keep track of the start of our list. This node then points to the next and to the next. And all these nodes are storing some data as well. Certain linked lists also have a tail pointer to represent the last element in the linked list. However, not all linked lists have this. Like the head, this is just a variable in memory that allows you to directly access the end of the list. As I explained earlier, the head represents the start of the list and the tail represents the end. There are also what we call doubly linked lists. These are linked lists that have pointers to both the next node and the previous node. This lets you traverse through the list either way, forward or backwards. Alright, let's take a look behind the scenes. Say we made a new list. Right now it has nothing in it, so the global variable size is 0. The head will point to null. Null is essentially the value to represent that there is nothing. There is no object. For linked lists, the end of the list must point to null, because that is a guaranteed way to signify that there is nothing left in the list. In this case, since there is nothing in the linked list yet, our head simply points to null. Let's suppose this is an integer array list. Say we wanted to add 17 to the list. A new node is created in memory and assigns the data value to 17. Then we point 17's node to null and the head to 17's node. And the global variable size increases to 1. Now we add negative 12 to the linked list. A new node is created with negative 12 as the data. This node then points to null, and we update 17's node to point to negative 12. And the size variable increments by 1. Now, say we wanted our code to insert a value of 47 in the middle, which is indexed 1. This is where the code is careful not to lose any data. It creates a new node with the value of 47. This node then points to node negative 12 as to not lose the pointer to it, and then we take 17 and point it to 47. And after a little rearranging, we see that 47 is now inserted into the list without any data being lost. This rearranging doesn't actually happen in code, but it is just a good visual reminder of what we just did. And finally, size is increased by 1. Now if we wanted to remove the last value, all we would need to do is set 47 to point to null. Because there is no longer a pointer to the negative 12 node in memory, this node is lost and cannot be accessed. In Java, the garbage collector automatically detects that it has no pointers and clears it from memory, and the size is then updated. Now if we wanted to clear the entire list, all that happens behind the scenes is that the head points to null, essentially cutting off the rest of the list, and the size is then set to 0. And that's all you need to know to understand the basics of linked lists. If you enjoyed it, feel free to like and subscribe. Thank you for watching.